Hey everyone, welcome to the last Ask Tom Database Security Office hours of 2022. I'm just shocked at how fast this year has gone. And we're looking at already the next year and planning the next Database Security Office hours in January. This month, I'm going to talk to you about some 5 or so underutilized database security features that are available in Standard and Enterprise Edition. So if you haven't joined us before, welcome. My name is Richard Evans. I'm a product manager of Oracle Database Security. I primarily focus on these Ask Tom events and Oracle Database Vault, but I can talk to you about any of our database security products, from encryption to key management to auditing, monitoring, data masking, subsetting, all sorts of good things there. All right, so like I said, if you haven't been here before, welcome. Thanks for joining us. This is our monthly call that is a direct channel with Oracle Database Security Product Development. We've got a partner event as well. So if you're an Oracle partner, there's a special session for you on the second Tuesday of every month. You're welcome to join that and ask questions, that maybe you don't want to ask in front of a general audience. This particular session is available to everyone, and it occurs on the second Wednesday of every month at 10 a.m. So we run them on Tuesday and Wednesday, second Tuesday and Wednesday of every month, one for partners on Tuesday and one for everyone on Wednesday. And we're going to have product announcements, upcoming event announcements, and then a technical presentation, which I'll deliver today, and then some Q&A time at the end. So you can ask questions that are not related to today's presentation. Can't promise I can answer them, can't really help you with support, but you're more than welcome to email me. I'll put my email in the Slack, the chat, not the Slack here. And if you want to email me with any of your questions offline, you're more than welcome to reach out. If you've got suggestions for things that we should cover, let me know. We're trying to do a lot of different things here, and we want to cover as many topics as you want to see. So I've put these QR codes throughout the presentation. So this one takes you to our Ask Tom website. So you can register if you haven't registered, and you can go back and see those old previous presentations. We've got almost 100 at this point, so that's great. And then I've got a QR code here to our GitHub repository, where I've put today's notes and example scripts or sample code or documentation link, anything that we talk about today or over the past few months. You should be able to find that on our GitHub repository for Ask Tom Database Security, and an easy little QR code for you to get there. Let's start with announcements. It's almost that time again, right? Every quarter, we're talking about patches. Patches are important. So we just got done with our October patches, hopefully, and then come January 17th on or around, we're going to release our first quarterly patch, our release update of 2023, collection of security and bug fixes for Oracle products. So not just database, but client and application and all sorts of different products that we support. As always, go check out oracle.com/security-alerts for more information and to see that quarterly patch release schedule that we put out there. So you'll see it through the end of the year. So if you're planning out next year's outage windows or patching cycles, then you could take a look at oracle.com/security-alerts and see when we're going to release those quarterly patches. Okay. DataSafe has some recent enhancements for December. So now you can schedule audit reports, predefined or custom. You can look at that audit report history there too. So we've got a 3-month back catalog of those reports that were generated. We allow you to schedule alert reports as well. So daily, weekly, monthly type of schedules there. And then also get audit reports kept for 3 months on that report history for you to review or go download. Actions now supports filtered alerts there too. So you got some more granularity with that, as well with granularity around audit trails. So you can filter by trail status to kind of help you identify issues more quickly if you've got a lot of audit trails that you're monitoring. And target registration supports the custom listener ports for cloud databases too. So outside of the 1521 or 1522 that you might be using. Oracle Support Corner here, we've got documentation or notes that are relevant to today's discussion. There's a couple out there on multi-tenant isolation and security principles in 21C and 19C. There's a micro support note out there on DBMS network ACL admin package with some examples, and we'll talk about that today. 18C schema only account. We'll create a schema only account in our example. And then just kind of the general information center for PL SQL in the Oracle database. So, always trying to learn about code-based access control, invoker versus definer rights, things that you can do a little bit better within your PL SQL. And I put all of these doc IDs on that QR code on our GitHub repository, so you should be able to access them now or at any time in the future. We've got a new blog post out there on blogs.oracle.com/cloud security. Peter Wall has put a blog post out there on Key Vault 21.5 and some ability to do secrets management and SSH connections. There's some really neat things that Peter has done and the development team have done with Oracle Key Vault. So beyond just managing, backing up, and being the online repository for your transparent data encryption keys, you can do secrets management, SSH agent items. There's lots of neat things that you can do with Key Vault as we've progressed through the versions here. So, and then, Nazi has got a blog out there on read-only audit roles that are available in AVDF 20.8. So take a look at blogs.oracle.com/cloud security for not just database related blogs, but just Oracle security blogs in general. This is something I haven't talked about in a while that I thought was relevant to talk about and always useful. There's an application that's available within the docs.oracle.com site that has to do with database features. And the quick link to get there is apex.oracle.com/database-features. And what it allows you to do is view information on features and licensing requirements. So you can get an idea of, hey, this particular feature was initially released in 21C. It's available on these different editions of the database or all editions of the database. So you can look across versions and you can look across features or license information to kind of get an idea of, hey, when did that come out? Or can I use that as a part of my license? This doesn't replace the licensing terms or anything, but we've tried to take the price sheets or the licensing information and make it easier to digest with this Apex application on database features. So take a look at that, bookmark it. And, I think I reference it a lot because sometimes I'm like, man, I don't remember if that came out in 18C or 19C. And I go take a look at that and that was an 18C feature. All right. Live Labs. Before I started the presentation today, I mentioned that I was in Austin working with some of our younger sales engineers, enterprise architects to learn Oracle database security. And everything that we're doing over this 2-day event comes from Oracle Live Labs. So you can get your hands on more than 40 security related labs. More than half of them are available to run on our platform. So there's no charge to you. So you can go over encryption, privilege analysis, database vault, all sorts of things. You can mask data. Hakeem has written a really, really successful live lab on defending yourself from ransomware, story of a hack. And then one of the sales engineers that's headquartered out of Austin, but based in the Bay Area, he and I have updated and created a new lab on autonomous database and Oracle Database Vault and migrating a legacy Glassfish application to the cloud and securing it in the cloud. So lots of really good stuff that we've got on that Oracle Live Labs page. And if you haven't joined us, take a look at our 23C beta program. 23C is the next long-term release of the Oracle database. And so you can sign up to see if you'll be selected for the beta program at tinyurl.com/Oracle beta, or use that QR code on the page there. It's codenamed App Simple because of the additional, just really the focus on development that we've put on this release. There's a lot of good security features, but there's a lot of emphasis on making things simpler for developers. So if you're developing in JSON, we've got a lot of new capability there. Take a look at it. I think beta 1 has started. I think beta 2 might be coming soon. So, if this is something that's you're interested in, put in the application and check out the 23C beta. All right, let's get started with today's technical topic. I'm going to talk about 5 underutilized database security features. And again, all of this that I discussed today is available on our GitHub repository with that QR code. So if you joined us late, you can take a screenshot of that. I put the code out there, the things I've worked on as a part of this presentation out there as well in a SQL script. Okay, so let's take a scenario where we want to load a remote file into the Oracle database, a comma delimited file, whatever it is we want to load in there. And we want to make sure that that file is in there and we can't modify it. So we want some immutability with this file. So the security team has come along and said, yeah, in addition to that, we want to make sure it can't be updated or deleted. We want to make sure that that database can only connect to this server. We don't want it connecting to any other servers. This is an internal server that we host. And so we want to control access. Maybe we want to grant some ability to add or remove when and how we can authenticate and utilize that service, but we really want to limit our scope. We want to limit those PL/SQL objects that can use the network. And then we really want to focus on least privilege. So the least amount of privilege that you need to get this job done, let's use those. So we're going to go through kind of these 5 areas here. We're going to talk about immutable tables to not update, to be able to prevent updates or deletes on that table, database network access control list, ACEs, so we can only communicate with that web service, PDB lockdown profiles, so that pluggable database can be controlled and it can't just use all these network-enabled PL/SQL packages and procedures. We want to use a schema-only database account to provide the least privilege to that procedure owner. And then we'll use code-based access control to really limit, what privileges the user has when they execute that privilege, when they run that privilege. Okay, let's start with immutable tables. Originally, immutable tables came out in 21C, but were backported to 19.11, and they are insert-only tables which exist and store data and can't be modified, right? So if you insert data in here, we want to make sure that that data is not able to be modified after the fact. So this example here is we create a compensation table that might be linked to the employees table. These are the bonuses. This is that information. And we want to make sure that we record it and there's nothing that can be modified. And we can't even delete this data until 90 days after it's been inserted. And we can't drop the table until a year after we haven't used this table. So as you can see, lots of immutability there, but lots of danger as well if I can't delete this table for a year after it's been modified. Now, I often like the persona of evil rich, so I want to go poke at this table and see what I can do and how I can, whether it's really immutable or not, right? So I ran these 3 commands, delete from, alter table to add a column or rename a column, and I got the same Oracle message of operation not allowed on blockchain or immutable tables. And so I said, well, that's fine. I'll go scorched earth, right? Like I'll just destroy it all. I'm just going to delete this user entirely. And it says, not so fast, Rich. Cannot drop blockchain or immutable table compensation. It's not allowed. Okay, fine. Then I'll drop the entire table space. Nope, there, right? So immutable means immutable, right? So, we want to make sure that when we're using an immutable table, that we really have a need for this immutable table. Okay. Now there are some use cases for it, right? Like maybe you do want to store this compensation. Maybe you've got some audit records that you want in there, but you also have to understand what you're getting. So understand that if you say no drop, it means you can't drop. So maybe use the no drop until so many days idle. Or if you say no delete, the soonest you'll be able to delete from that is 16 days after insert. Okay. And then there's some other kind of limitations there, right? Cannot update rows, merge rows, add columns, rename columns, drop partitions. So we've got to be sure that we're utilizing these immutable tables, that we really mean immutable tables. Now, you can flash back the database and do a point in time recovery, but you can't flash back that particular table. I've created all of this in a virtual environment. So when I was testing this and working with it, I could basically just restore my VM environment, my VirtualBox VM to that last snapshot. So that's, how I got around that. It does rely on system time. So you have to control who has access to that operating system, just like you would in your day-to-day life. You don't let just anyone on that database operating system. Blockchain tables are very similar to immutable tables, but they provide this ability to add kind of this crypto digest to it. So we don't have to have a dedicated blockchain only database for this. We can utilize this converged database concept that Oracle has, where we've added these as features, JSON features, blockchain features, immutable table features. We've got this capability as a part of the Oracle database. And then this feature came in 21C as well, but was actually backported to a version right before immutable tables, so 19.10. So if you're running a 19, hopefully you're up to maybe 1916. I think that's one of the latest releases that we have on our 19C patch set, quarterly patch set. But you know, you've got that capability with 19C as well. So let's kind of take a look at some use cases of blockchain. You know, I think we hear about blockchain all the time. Like we hear about it in terms of, you know, cryptocurrency primarily, but there are some use cases when it comes to assets or financial accounting or degrees or certifications in the education world. You know, maybe legal documents. You got a chain of custody type of operation there. Corporate data, right? The compensation example that I've talked about. We want to make sure that that record hasn't been manipulated, and we can verify it with our DBMS blockchain table verify rows. So if you have an independent auditor that wants to validate this, you can export, you know, this crypto digest, you can export the results there, and you can say, hey, now compare it to what we're seeing in the database. And yes, it's all still the same. There haven't been any modifications or changes to those rows once they've been inserted. So built on immutable tables and that idea, adding that crypto digest, relating it to the previous row, you know, there is some use case there for blockchain tables. But again, maybe not every use case. There are some restrictions on that. You know, currently can't be used with distributed transactions, label security, or VPD policies. You can't convert a table to immutable or blockchain or vice versa. And then blockchain has got some restrictions there where it exports it as a plain table, a regular table without those system generated hidden columns there. So again, tamper resistant. If you have a requirement for it, we have the capability within the Oracle database. And if you're on our 19C.10 and higher, you've got the capability to utilize, take advantage of blockchain tables within the database rather than standing up an entirely separate database there. You know, blockchain is just yet another thing that we add to our maximum security architecture. You know, it has a place, it has a need. If you have used blockchain or immutable tables, I'd love to hear about it because I think they are very powerful and they're going to get better as the market matures, as we mature, as we understand like different use cases and how we can fully take advantage of this capability. But again, yet another offering in our maximum security architecture. When I put this slide deck together, I was trying to understand like, okay, well, how does this compare to other things? And, you know, how do I get this straight in my head? And so I created this matrix here where I've got, okay, the baseline is database privileges, right? So grant select, grant update, grant delete, grant drop table, these privileges. And then we look at our data row level controls or object controls of VPD, label security, database vault. So can you prevent row select and row insert? Yeah, you could do that, but that's not the purpose of immutable tables. That might be the purpose of privileges or database vault. Immutable tables really shine when we're talking about updates, deletes, truncates, drops, modifications, those type of things. That's not where we're going to use like a VPD or a label security or a real application security. We're going to use, you know, privileges. We're going to use database vault. Or if we're truly saying we don't want to drop that column, we don't want to modify that row, that's when we get into the immutable tables. And if we say we need some cryptographic hash that's based on that previous row, well, that's your blockchain tables. We don't have that capability with immutable or with database vault or adding row level security with label security or using virtual private database there. So again, you know, Oracle has a defense in depth approach where we are trying to provide overlapping security controls that allow you to take advantage of our capability and then pair products together to make sure that you're getting, and covering all angles of security. PDB lockdown profiles are something that were released in Oracle 12c Release 2. They allow you to restrict operations and functionality within that pluggable database. So if you're running a kind of a shared services type of environment, and let's say you've got an Exadata or you've consolidated on multi-tenant, this is a fantastic tool because not every pluggable database owner or sys in PDB or PDB DBA user is going to need to modify these settings, right? Like you want to create a baseline for your pluggable databases and then, ensure that some databases have that capability and others don't. And, PDB lockdown profiles are a really powerful addition that you can use in your multi-tenant environment. So let's go through an example here where we're going to create that lockdown profile, just sec profile, security profile. As you can see, it's one of 4 that we have in our database. These other 3 are default ones that you can utilize if you were thinking about the concept of like a private DBAS, public DBAS, or a software as a service. You can utilize those and then add to those. I went ahead and just created a security profile as my example. And now I'm going to add in what I want the security profile to disable. Now you can choose enable, you can choose disable, and we can get down into kind of the nitty gritty of details on that later in the slide here. But to start with, I want to disable all alter system set commands. I want to disable partitioning. I want to disable network access. And now you can see that my lockdown profile has those rows and rules in there as a part of that profile. Now I'm going to apply that profile to my PDB1 pluggable database by altering the system and setting that PDB lockdown profile to be my security profile. And if I want to see what the value is as sys, I can look at the parameter PDB lockdown. I can see that the value is set to security profile. And then I want to be evil rich and I want to start changing things, right? So, okay, I'm going to set the cursor sharing to exact, insufficient privileges. Well, then fine, I'm going to get rid of this profile entirely and reset my PDB lockdown profile. Sorry, can't do it, right? So this sys user inside of the pluggable database can't modify these parameters. It can't change the settings or the features or the capabilities of this pluggable database. It's been inherited from this PDB lockdown profile that we created in the container database. Now let's say, okay, well, I do need to flush the shared pool once in a while, so we will allow the profile to flush the shared pool. So we enable that clause for the alter system statement, and then we can see that we've got it enabled as a status. Everything else is disabled or empty. That particular rule and clause is set to enabled. Now, when I go back into my pluggable database, I can go ahead and enable, I can go ahead and flush the shared pool, but again, I can't break myself out of the PDB lockdown jail that I've applied to this PDB1 database. So again, evil rich can't be manipulative here and break himself out. Now, let's say we've got developers working in this environment and they say, well, I need to do some PL SQL debugging. There's some stuff here. I like to set some of these warnings to a higher, so I have it makes it easier for me. Okay, cool. We can enable, options there. So we're going to disable all alter systems except these 3 options. And then we can see what it's set to. We can set it, we can change it, we can, enable it, we can turn it back. So we can control and allow the administrators within that pluggable database to set this parameter. One of the ones that I think is really, really useful is being able to control the alter system when it comes to CPU count. If you're working in a consolidated environment, you know that sometimes some of these pluggable databases get the application consumes maybe a little more resources than you'd like in a shared environment. And so you've limited maybe the CPU that's allocated to it, and you're using resource profiles, resource manager to control that. But if you've got some really smart line of business DBAs that have access to this pluggable database, they might realize, oh man, this Exadata has a lot of CPUs. I could make myself look good if I bump this to 32, right? I want my application to run the fastest in this shared environment. Not so fast, man. We're going to go ahead and limit that to a minimum value of 4 and a maximum value of 8. And we're going to allow that sys user to change it within that range, but not above or below. Okay, so really powerful capabilities here with that. PDB lockdown profiles can actually inherit some disable rules of a base profile. So if you did want to have a base profile and you want to create a new profile, HR profile, and you want to include all of those disable rules from the base, that private DBAs, you can do that. So you can kind of stack the profiles together. So, we've got that capability there. If you want to make a copy, you can create a static profile and copy the private DBAS profile to our new profile. So we start from there. I think the verbiage in PDB lockdown profiles is really powerful. So we can enable feature all except for these things, or we could disable feature all except for these type of features. So really a lot of flexibility when it comes to deciding what to enable or disable within this PDB lockdown profile. And I would point you to table 11.1 or -1 in that 19C SQL reference guide. So you have an idea of the feature bundles that are available to you, as well as, the features within there too. So lots of capability. And again, okay, where does this fit in the overall kind of defense in-depth capability that we have here? So I tried to break this up into different sections. This first section is features, database capability, the ability to execute packages or procedures that access the network or utilize Java runtime. That is exactly where PDB lockdown profiles shine. There's some stuff you can do with privileges, but, util TCP, util HTTP, I think is granted to public. So we're not controlling that way. We're controlling it with network access controls. There's some things we can do with database vault and whether we allow some of these interactions, but this is the bread and butter of a PDB lockdown profile, is limiting, some of these OS interactions, changing of the system commands, Java runtime features, AWR snapshots, those kind of things, but not necessarily data, right? We're not talking about PDB lockdown profiles preventing truncate of table or DML select commands. That's focusing on the infrastructure where we can utilize database vault, label security, RAS, VPD, or just plain database privileges for those capabilities. And then, if we want to make policy decisions on who can access the data, well, that's real application security or VPD if you want to write your own PL SQL. We want to make context-aware decisions. And what I mean is, hey, this user is logging in from this IP, or they're using SQL Plus or a JDBC thin client, or coming from this host, or we've got this custom user context that we've created. That's where our VPD, RAS, label security, database vault can make those decisions. Database privileges can't. They're just binary. You either have the privilege or you don't. Lockdown profiles are very similar. You either allow the privilege or you don't, right? So, and there's some exceptions that you can do in there, but they're not exceptions based off of where the user's coming from, who they're logged in, whether they're an enterprise identity or anything like that, like you can make with VPD, RAS, label security, and database vault, okay? So, kind of a little, where do things play? Again, defense in depth, right? Defense in depth. To talk about it a little bit differently, to kind of try to show you a picture of it, Database Vault can provide context-aware prevention to limit your administrators from accessing application data, or how those application credentials can be used, where they can connect. Blockchain or immutable tables can restrict changes to the table, the rows, and provide that row integrity if you're looking for it. Label security, RAS, or VPD can do database row level security, and it can be context aware there too, where pluggable PDB lockdown profiles are what kind of under the covers are disabling network access or Java or OS access or enabling particular commands, clauses within the alter system capability there. So they all have a place, they all go together, they all work together, and they solve different problems and close, limit different security gaps maybe within your infrastructure. Okay. Network access controls have been around since 11G release 1. And in 12C release 1, we introduced this network access control entries to replace manipulating the ACLs directly. So they're an interface to the access control list. They allow you to append a host ACE or a wallet ACE if you're using a secure connection, remove the same kind of thing there. And so they look like this, right? So if we're gonna try to reach out of the database and we've got this PDB lockdown profile enabled where we've blocked that network access, we're gonna see an insufficient privileges here. We can't utilize the underlying capability here, this util HTTP, to get out of the database. So what we want to do first is enable that in our PDB lockdown profile. So we want to enable this package to be used as a feature, and any PDB that has this profile will now be able to utilize the util HTTP package. But our network access control entities and entries and ACLs still prevent that package from reaching the internet. So we're saying, hang on, I know you can execute it, but I haven't been told what you can access and how you can utilize this network access capability. So we'll see this error message here that says, hey, it's denied by an access control list. And then we enable that using our DBMS network ACL admin. And this is where we utilize that feature of append host ACE, access control entries. And we say we want the privilege of HTTP and HTTP proxy for this user a role. And then the principal type is really just a database user type. This kind of follows the RAS, the real application security principles of application users and database users. And so in this example, we're using a type of DB, and so it's a database user. And then if we go query the ACL and the ACE views, we can see that we've authorized access using HTTP proxy or HTTP for this particular user data owner to connect to this specific IP address that's internal. Okay. So again, defense in depth, we've stopped the use from the PDB entirely with PDB lockdown profiles. Now we've got our network access control list that say, well, hold on, you haven't told me where they can connect and who can connect. And so we authorize that with our append host ACE. All right, so if we wrap that with code-based access control, we can do some really cool things. So in 12C released this idea of accessible by and code-based access control. If you've looked at any of our kind of internal packages, procedures, functions, types, you might see that some of them have this accessible by clause associated with them. So we want to limit what can execute these PL/SQL units or subprograms. And so, hey, you've got to go through this other program in order to get to this program. I'm not going to let you execute it directly. The example I have for you today is around code-based access control, where we want to grant a role to our PL/SQL object so we can practice least privilege and we can kind of reduce the risk around granting that to, a wider audience there. So we're going to take a look at this code-based access control that's available to you in 12.1 and higher. So we've got a function that we want to be able to look at DBA users to see when that user was created, right? We're going to take advantage of this 18C feature of schema-only accounts, where we create this data owner with no authentication. So it has no password. Even if we granted it create session, it couldn't create session. This is where we're going to store our procedure. And so the only privilege data owner needs is create procedure. We do need to give it read on that view in order for it to compile this procedure. Now there's ways around that I'll show you in a second more advanced example with dynamic SQL. But for this use case, we're going to give it read, and then we're going to create a user that is going to be our user, our data user, who's going to execute this privilege and be able to access the results of it. But really, the only privilege that that data user has is the ability to execute the function when we create it, and then connect to the database. It doesn't have read on the view. It doesn't have any of those kind of capabilities there. So here's my function that I created with invoker rights. Okay, so I've got auth ID as current user. So it's utilizing the rights of whoever invokes this function. And all it does is select the created column into a variable and then return it to the user. So we can use it in like a select function from dual capability, okay? So the first thing is when I compile it, I'm going to try to execute it as my data user. And it says, sorry, man, you told me to use invoker rights, but data user doesn't have access. This table or view doesn't exist. I don't know how to access it. I have no privileges to do it, okay? So it fails. It fails. Now, what we want to do is use this code-based access control by creating a role, granting that read on DBA users to the role, granting the role to the data owner because it is required to have it in order for us to then grant read to the function. So we can grant the role to the function, our date created function. And now when we execute it, we've got the ability to see that data with those invoker rights, okay? So we couldn't do this before, but we can do this now. We gave that user, I just copied the last statement from the previous slide where we granted the role to the function. And then when we execute it as data user, now we have that capability to do it. It's taking advantage of that least privilege and that read on the DBA users that was granted to the role, which was then granted to the function. So if you want to try this out, I created the script to do all this and I put it in the GitHub repository and it is available to you so you can utilize. And I will also share the link to it here in the chat as well. Okay. And so you can run through this exercise as well. And it goes through, revoking that role from the function and then running it again and seeing that it fails and then granting it and then seeing it succeeds. And so we're utilizing that code-based access control there. So again, really, really least privilege model that we've got there. All right, so now let's say we want to incorporate access to this network ACL admin package, and we want to create our own package called authorize ACL auth package. And what we want to do here is to continue our example from the beginning where we can enable the host ACE access to our server or disable it as the user, right? So we don't have to bother our database administrators all the time. We can create a package that's got kind of the least privilege to do so too. So again, same thing. I created my data owner that's going to own the package. I gave it create procedure. That's the procedure it needs. And then I'm compiling my package in there. So you'll notice that I didn't give it anything else. I didn't give it read on any tables. I didn't give it execute on this DBMS network ACL package. I've been able to compile my package. Now we get into the CBAC portion where we create this role. We grant the role to data owner and we grant execute on sys.dbms network ACL admin to the role. And remember, now we're granting that role to the package. Previously, we granted a role to a function. Now we're granting it to a package. So you can grant that role to a package, a procedure, a function. And here we're using it as an example with a package. Now, I want to enable that util HTTP again. I did that in a previous example. So this is just to ensure that we have that capability within that pluggable database. We're going to grant execute on that package to our data user. And then our data user can run it to grant access to set up that host ACE, that access control entry in the database so it can access this particular server. So let's say I had a self-service model where I wanted users to be able to do some of this or something like this. I could have my package check the IP that they were trying to connect to. Hey, you can't connect to external IPs, but I will let you connect to some internal IPs and grant yourself access. I kind of think of it similar to my badge at Oracle. I can put myself on general access to almost any facility that Oracle has. I can't give myself access to the data center. I can't give myself 24-hour access, weekend access. I can't give myself access to particular rooms or the executive suite. But there's just a general level of access that is understood that I need. We could create the same kind of capability here for allowing network access from the database, but only to certain IP ranges or within our, our intranet. Okay. So now when I execute the command and I load data and I pull down this daily CSV file and I load it into the database, when I'm complete, all I have to do then is revoke that access. So again, I'm back to this least privilege model where the database can't connect to this IP address, but it can when it needs to run the proper procedure, when it runs the procedure it needs to load the data. I got around the need to grant execute on that package, that DBMS network ACL, by using dynamic SQL. Okay, so typically what would have to happen is the data owner would have to execute this specific statement here, right? Well, I wrapped it in dynamic SQL. So it compiles and the package doesn't know that it's calling it, but it does get those privileges from the role that I granted to the package, right? So I changed my code a little bit here. I modified this. I could have done the same thing in the last example where instead of calling the table directly, I called it within dynamic SQL and then I did an execute immediate to execute that SQL. So then I wouldn't even have to give data owner that read on the view. So there's lots of ways that you can even further limit the control here. Now, there are side effects of using dynamic SQL. I am not a performance and tuning expert by any means, but I know that there's some limitations or, parsing that goes on here that may affect you. So this may not be the right solution to you, but just understand that you can still work toward a least privilege by granting the privileges to a role and then granting that role to a function, package, or procedure, and then limiting who can execute that and executing it as an invoker instead of a definer. Okay, lots of really cool capabilities with code-based access control. All right, let's kind of summarize here what we talked about. We used an immutable table to make sure that new rows couldn't be inserted or couldn't be updated or deleted. We used network access control list to ensure that only that web server was what the database could connect to, and only as that data owner user. We limited the use of network enabled PL/SQL packages and procedures with our PDB lockdown profiles. And we also limited Evil Rich from giving himself 32 CPUs on his PDB, right? So we utilize the capabilities of PDB lockdown profiles to solve a couple problems there. We created a schema-only database account, so it has no authentication. Even if you granted it create session, it doesn't have a password, so you can't authenticate to it. But we're utilizing that to store our procedure. So that's our procedure owner. So we're separating that from our procedure executor, right? Our data user who runs the procedure. And then we utilize code-based access control to grant the privileges to a role, and then grant that role to a function, to a procedure, or to a package, and then running that with invoker rights. So we're really, really least privileged. We're not utilizing the privileges that were granted to that procedure owner. Covered a lot of stuff. I've got, again, the slides, or I can share the slides if you don't mind. I've got the examples out there on our GitHub repository. You can always email me if you have any questions, any comments, anything like that. Again, here's the link to the GitHub repository. You can use this QR code to go and check that out and see what we've got out there. We've got 3 or 4 months out there now. I've been trying to do this here for a little bit, and I'll continue doing it going forward. And then thanks for joining us for the last Ask Tom Database Security Office Hours of 2022. We're going to start 2023 by talking about some advanced data masking tips and tricks. How about that? And some group by, some things like that. I'm going to try to talk Hakeem into coming on and teaching us all about that, whether it's data masking and subsetting or utilizing data safe.